Hello students. Okay. You people have got the new link, right? So come fast. There was network issue. Fast, fast. Come fast. It's already late. Means problem was with respect to network. Rakshita, Sukruta, then Vivek, Meghana, yes. Fine. So in that case, whatever I have written on the board, I mentioned that one as important. If it is asked, it will be for 2 to 3 marks. 3 marks question. Difference between lanthanides and actinides. Right? So these are some of the simple points which I have mentioned. So 4F series, 5F series, absorption with respect to narrow spectrum absorption, wide absorption spectra. Here it is naturally present, but all of them or most of them they are radioactive and all of them are synthetic. Then higher magnetic momentum, lower magnetic momentum, then forms less basic compound and forms more basic compound. Then you can even mention actinides will have wide range of oxidation state, where common oxidation will be common for both +3, but here maximum will be +7, wide range. Here it cannot go up to +7, right? So that's where we have some of the difference. Fine. So we can mention that one as important differences between lanthanide and actinides. All of you have understood? Fine. So that's what from this particular chapter, lanthanide contraction they have asked many times. Then they have asked about preparation of KMnO4. Okay, sorry. Fine. So from this chapter, important one here is lanthanide contraction. Then sometimes they have asked about actinide, but lanthanide contraction is very important. Then preparation of KMnO4, preparation of dichromate. So these are the three very important ones. Then after comes the difference between lanthanide and actinides, and for 1 mark here and there they will ask the question. So Meghana, you were asking something? You were asking something? All of you are here, right? So these are some of the concepts you should be practicing from this particular chapter. Okay? So 1 mark question in chemistry, please remember, we cannot tell this will be the question or these are the questions which will be asked. 1 mark question it can be or it will vary year to year. But 3 marks or 2 marks question we can tell. Okay? So all of you have understood? So this is what with respect to D and F block element. If you guys are ready, shall we solve some of the competitive exam questions? Okay? So all of you have writing pad and all, because I will be writing the question on the board. Fine. So shall we start? Question I have written. So I will write it on the board. Okay? So the first one. Scandium, atomic number 21, is a transition element. Is a transition element, but zinc atomic number is 30 is not. So it is a CET question. Okay. So option for this one is both scandium and zinc ions are colorless and form white compounds Option B, in case of scandium 3D are partially filled, but in zinc completely filled. Option C, last electron assumed to be added to 4s level in case of zinc, and the last option is both scandium and zinc do not exhibit variable oxidation state. All of you are here, right? All of you are writing the questions. So that's what scandium, they have given the atomic number, is a transition element, but zinc is not. Okay, so these are the options. Both scandium plus 3 and zinc plus 2 ions are colorless and forms white colored compound, or which forms white color compounds, Then in case of the scandium 3D are partially filled, but in zinc completely filled. Last electron assumed to be added to 4s level in case of zinc. Both scandium and zinc do not exhibit variable oxidation state. Fast. That's it. It's live.
Yes, sir.
Oh, okay. Option. Oh, I didn't see. So option 2. Okay. Option B. Yes. Very good. Because when it comes to scandium, what should be the electronic configuration? It will be argon. Since it is having 21, it will be 3D1 4s2, right? So 3D1 4s2, first element in that particular period. This is the first element. So now when it comes to zinc, which is the last element, electronic configuration will be 3D10 4s2. So these are the electronic configuration. Now when it comes to second one, that's where it is having partially filled, that's where it is having completely filled. If I see the option C, added to 4s level in case of the zinc, so there is no option, it is completely filled. Last one, both scandium and zinc do not exhibit variable oxidation state. That is not true. Zinc will have only restricted with +2, but scandium can show +1 also, +2 also, +3 also. Okay? So that's where we have the option B, which will be the correct answer. Okay? So zinc can also be called as Due to that,
Pseudo transition.
zinc can also be called as pseudo transition element. Due to that, zinc will be included in a pseudo transition element. Why? What is the reason? Because in its ionic form or in a elemental form, it will be having completely filled d subshell. All of you have understood? So we will move to the next one. Second one. Mercury is a liquid metal. Mercury is a liquid metal because it is also a CET question. Option A. It has completely filled. It has completely filled d orbital. It has completely filled d orbital, which prevents or that prevents dd overlapping of orbitals. dd overlapping of orbitals. Option B. It has completely filled d orbital, which causes dd overlapping. dd overlapping. Then option C. It has completely filled. It has completely filled s orbital. It has completely filled s orbital. Then option D. It has small atomic size. It has a small atomic size. Yes, which one? Okay. Anyone? Mayank has given the answer. Anyone? That should be option A, because mercury is in the same group to which zinc belongs to. Just now we have discussed zinc is having completely filled d subshell. Same logic is applicable for mercury also. Now, all of us we know that metals, they are in that particular metallic character due to the presence of metallic bond. That is due to the presence of metallic bond, where there will be distribution of electrons which are freely available, or we have the electrons which are loosely bound to the metal or which is loosely bound to the nucleus. So that's where we have the existence of the metallic bond, right? Now since there is a completely filled d orbital, so these electrons may not be available for the interaction. So that's what the first statement talks about. So due to that, option A should be the answer. Okay? So option B cannot be the answer. Now it has completely filled s orbital. That's fine. S orbital, since it is having more nuclear force acting on them, they will not have much impact in forming the metallic bond. Now next one, small atomic size. No, mercury is down the group. So it should be having pretty higher atomic size only. Fine. So that's where we have the option A, which should be the correct answer. Due to that, it will be a liquid metal. Fine. Option A should be the answer. Any doubt in this? So shall we move to the next one? Okay. So next one is manganese plus 2 compounds. Manganese plus 2 compound are more stable than Fe plus 2 compounds. Fe plus 2 compounds towards the, what continuation is that, towards the oxidation to that, towards the oxidation to that plus 3 state, towards the oxidation to that plus 3 state, because option A, Mn plus 2 is more stable with high ionization enthalpy. That means third ionization enthalpy. Option B, manganese plus 2 is bigger in size. Is bigger in size. Option C, manganese plus 2 has completely filled d orbital. Next one, option D, manganese plus 2 does not exist. Anyway, straight away option D cannot be there. Which should be the answer. Okay, Mayank has given the answer. Any one of you? Okay, Jannavi, very good. Option A. Yes, option A should be the answer. Because all of us we know that manganese is having atomic number of 25. All of you will agree? So therefore it should be having electronic configuration as argon 3d5 4s2, right? So naturally it should be having manganese plus 2 will have argon 3d5 4s0, stable electronic configuration. Manganese plus 2 is having stable electronic configuration. It wants to, if it wants to go for Mn plus 3, that's where we have the third ionization enthalpy. So if that is the case, it will become argon 3d4 4s0. Since there is a stable electronic configuration here, it demands high ionization enthalpy, that is third ionization enthalpy, right? So iron, all of us we know, iron is next to the manganese with 26. So electronic configuration should be argon 3d6 4s2, right? Argon 3d6 4s2. Now we are talking about Fe plus 2. Fe plus 2 means it will be argon 3d6 4s0. If it is Fe plus 3, then it will be argon 3d5 4s0. That's where stable electronic configuration, Fe plus 3. So due to that, Fe plus 2 can easily go for plus 3 oxidation state, but not manganese. All of you have understood? So that's where we have the answer as option A. So this one, completely filled d orbital, is not the correct answer. It is half filled. It's not completely filled. Okay? So that's where we have the answer as option A. So we will move to the next question. So this one was asked in comment K. Earlier it was there. Anyway, now it is neat. Next question. Once again from comment K. A transition element. Next question is 4. A transition element. A transition element with atomic number 24 will have its magnetic moment will have its magnetic moment. Option A, 5.92 Bohr magneton. Option B, 6.93 Bohr magneton. Option C, it will be diamagnetic. It will be diamagnetic. Option D, greater than 8 Bohr magneton. Greater than 8 Bohr magneton. First, which should be the answer? Right? So 24 atomic number they have given. Right, the electronic configuration. Okay. Janavi, Kirtana, okay, very good. Option B, okay, fine. Now, 24, anyway, element may not be required, but I will write, it is nothing but chromium. Right, atomic number 24 means it should be nothing but chromium. We should have the argon 3d5, 4s1, right, argon 3d5, 4s1. So naturally, d subshell, all the orbitals have unpaired electrons. All the orbitals they have the unpaired electron. Along with that, there is one unpaired electron at 4s subshell. Right? So total how many are there? 6. That means total number of unpaired electron is 6. Now you can calculate by using the formula, that is magnetic momentum is equal to square root of n into n plus 2 Bohr magneton. Now if you solve it further, it will become 6.9, right? So that is nothing but, so n is 6, so 6 into 6 plus 2 is equal to square root of 48. Okay, so square root of 48, so that will give the answer 6.93. Okay, so that's where we have the option B as the answer. All of you have understood? So you have to write the electronic configuration, otherwise you will not come to know how many of unpaired electrons are present, because you have to find out the n value. So based on the magnetic momentum, many times they have asked, please remember in your exam, competitive exam also, and even with respect to the board exam also. Oh, that is also another important concept in D and F. Okay, na? So next one. This is once again AIIMS. Earlier it was the All India Medical Test, this one, right? So full form I have forgotten. So choose the correctly paired. Choose the correctly paired gaseous cations. Gaseous cation and its magnetic moment. And its magnetic moment. Option A, titanium plus 2, 3.87 Bohr magneton. Option B, chromium plus 2, 4.9 Bohr magneton. Then option C, cobalt plus 3, 3.87 Bohr magneton. And the last one is manganese ion, Mn plus 2, 4.9 Bohr magneton. Once again, you have to find the electronic configuration. Oh, see, they have not given the atomic number. That's why I told minimum up to 40 atomic number you should be practicing. Okay? Now if I say titanium, which is next to the scandium, so it will be having 22, right? 22. So naturally titanium plus 2 should have the 3d2, right? 3d2. That was 3d1 in scandium, 3d2. That means n is equal to 2. N is equal to 2. Same way, we have the chromium plus 2. Chromium is nothing but 24. So plus 2. Therefore, it should be 3d4. So what will be the n value? N is equal to 4. So next, cobalt plus 3. Cobalt is nothing but next to iron. Yes, 27. Cobalt 27. It should be having 3d6. N is equal to, once again, 4. Okay. So now next one, manganese. Manganese plus 2. So it should be 25 just before to the iron. So it should be having 3d5, right? So n is equal to 5. So substitute these values into this equation. Square root of n into n plus 2 Bohr magneton. So in first case it is n value is equal to 2. Second case n value is equal to 4. Then n is equal to 4. Then n is equal to 5. Have to find out. So which should be the answer? Option B. Whether option B will be the answer? Yes. It should be option B should be the answer. Fine. So that's where we have the option B as the answer. Okay. Next class is there. Anyway, I will stop here in that case. What I will do is, whenever next my class will be there for you people, first few minutes we will solve some more questions on this chapter. You should be reminding me, okay? So we will solve some more questions on this chapter, okay? Now I will stop the session. Any doubts? So D and F we have done. So next class we will solve some more questions on this chapter. But any doubt? Okay. Okay, fine then. So take care. Bye.